Hi guys, I'm Professor Adrijana Savic. I'm teaching at Kennesaw State University, and today we will talk about equilibrium of a particle. So what you have to know is free body diagrams and why we need free body diagrams. Free body diagrams are one of the most important things for you to know how to draw and use them for statics and any other courses. So what is free body diagram? It is drawing that shows all external forces acting on the particle. When we are talking about external forces, we can say, okay, we have a wind as external force. Then we have a snow as external force, rain, earthquake, people on the bridge, people on the structure, trucks on a bridge, cars on a bridge, etc. All of them represent the external loads. So why we need free body diagram? Because that is a key to being able to write the equations of equilibrium, which are used to solve for the unknowns, usually forces or angles. So here you have a different type of external loads. You have more of these. I just mentioned wind, snow, earthquake, people, car, trucks, but also we have earth pressure, we have water, etc. So all of these represent external loads. So how we are drawing free body diagram? Firstly, we need to imagine the particle to be isolated or cut free from its surroundings. So we need to show all the forces that act on the particle. We have active forces, they want to move the particle, and we have reactive forces, they tend to resist the motion. So using the third Newton's law, force of action is equal to force of reaction. That is our step number 2. Then the third step will be to identify each force and show all known magnitudes and directions. Show all magnitudes and direction as variables. So for instance, we have here 3 forces. We have a cylinder with a mass of 40 kilograms. To represent that as a force, we need to multiply with gravity, which is 9.81. So we will obtain the force at point C to be 392.4 Newton. Then, if we have a particle A, from A to B, we have some rope, and that will represent our force from A to B. In this case, it is notated as FB, and we have some angle of 30 degrees. And also from particle A to D, we will have some force in rope again, and we will represent that as a force FD. So what we are doing next? So we have that particle A is in equilibrium. That means that sum of all forces has to be equal to 0. So that means FB plus FC plus FD is equal to 0, or sum of forces is equal to 0. In general, for particle in equilibrium, we have the sum of forces is equal to 0, or sum of forces x in y direction plus sum of forces y in j direction is equal to 0. So, or written in a scalar form, sum of forces in x is equal to 0, and sum of forces in y is equal to 0. So these are 2 scalar equations of equilibrium. These equations can be used to solve for up to 2 unknowns. So in this case, we have the first equation of equilibrium, that sum of forces in x direction is equal to 0. And what we have only force from A to B, or a rope, which is FB times cosine of 30. And we have a force from A to D, which is minus FD is equal to 0. From the beginning, we assumed that all of our forces are in tension. That means that they tend to pull. If we obtain our result as a negative, that means that our forces are pushing, that means that all of them are negative or some of them are negative. So the first equation was this. The second equation, we have that sum of forces in y direction is equal to 0. So that means using the trigonometry, FB times sine of 30 minus, and what we have also only the cylinder, that means minus 392.4 is equal to 0. So you solving these two equations, we have that FB is equal 785 Newton, and we obtain that FD is equal 680 Newton. Bearing in mind that FB force has to be resolved into two, so we have FBX and FBY, and FBX will be this force times cosine of 30, and FBY will be this force FB times sine of 30. So both of them will go in a positive direction because FBX is in X positive and FBY is in Y positive. FD is in a negative X direction and FC is in a negative Y direction. This is one example. We have the members of a truss are connected to the gusset plate. If the forces are concurrent at point O, we need to determine the magnitudes of F and T for equilibrium. We will take for theta to be equal 30 degrees. And I put as a red mark for our forces in X direction. So we will have known force of 8 kilonewton at point A. Then we have T force, or it is a member B. T force has to be resolved in two components, Bx and By, and since that we have here angle of theta, which is given to us to be 30 degrees, our Bx will be B or T times cosine 30, and it will be a negative direction because it is opposite of positive x-axis. And we have By, again using the trigonometry, we will obtain that By is equal minus B times sine 30. Then we have F, which is a positive direction. Then we have a force D, which is given to us as a 5 kilonewton. Again, we need to split them into dx and dy, and we have angle of 45 degrees, so that means dx is equal d times cosine 45, and dy is in negative direction, and it has to be equal d times sine of 45. Using the equation of equilibrium in x direction, we have this force known of 8, then we have dx, which is 5 times cosine 45, that is 3.54 kilonewton positive, and we have this B or T force, which is the same, times cosine of 30, so in a negative direction. So this one, B, is our unknown. Then we are using the second equation, the sum of forces in y direction is equal to 0. That means we have By, which is negative again, and By will be B times sine of 30. Then we have minus dy, which is here given as 3.54, and we have F force in positive direction, so plus F to be equal to 0. So our unknown will be B and F, and we have two equations of equilibrium. So solving these two equations, we will get that B is equal 13.22 kilonewton, and our force F is equal 10.2 kilonewton. So B and T are the same. So T is equal 13.22 and F is equal 10.2. So don't be confused. Here is B. That's why I put here Bx and By, and they are requesting from you to find the value or magnitude of the force T. So T and B, that is the same. So this was the example regarding to equilibrium of a particle. The first step is to draw free body diagram, including all external loads which are are given to you. So for external odds, we mention wind, earthquake, earth, snow, rain, trucks, cars, etc. Then we are writing equations of equilibrium, and we can write only two equations of equilibrium because we have forces only in x, y, and y direction, and that will give us solution only if we have two unknowns. That was it for today. Thank you for your attention.